budgeting. Capital budgeting under uncertainty is divided into 2 or probably 3. But the first one was probability-based method or statistical-based method, where we have calculation of expected value of cash flow, calculation of variance, calculation of coefficient of variance, calculation of standard deviation, and we're able to know whether the company is risky or not. The second part, which we're about to start, is the non-statistical method or non-probability method, where we're expected to calculate risk-adjusted discount rate, or calculate certainty equivalent approach or method. And the last one will be sensitivity analysis method. And like I said, there is stimulant, but we're not going to do that. And the other one, which is capital rationing, but we may not bother about. But what's important here is this: we're going to concentrate on non-probability method. In that method, we're going to find out how to calculate the risk-adjusted method. In that method, we're going to have 2 types of risks. One is risk-free rate, and the other one is risk premium. Risk premium.
Which one is that, sir? Which one is that?
So we're looking at this. I said we're looking at capital budgeting under what? Uncertainty. 1, we have treated last time. Probability.
No, come again, sir. Come again. You know, last time we treated under uncertainty.
Yes, uncertainty. And that uncertainty is divided into 2 that we are going to treat based on the course outline. The first one we did was probability-based method, where we calculated expected value, remember?
Yes, sir.
Calculated expected value, coefficient of variance, and so on. And the one we are going to look at today is non-statistical. Non-statistical based method. Under this one, we're going to look at 1, risk-adjusted discount rates. That's the first one. Second one, we're going to look at certainty equivalent method. The last one we're going to look at under this is what we call sensitivity analysis approach. Is it clear now?
Yes, sir.
So these 3, immediately we finish these 3, we have succeeded in understanding capital budget under uncertainty. So this is a part 2 of that capital budgeting under uncertainty. So I'm going to start with the first one, which is risk-adjusted discount rate. That's the one I'm talking about, that for us to apply that method, we need 2 risks. One is called risk-free rate. Risk-free rate. And we're going to be giving again risk premium. So we'll add the 2 together to know what to do. But meanwhile, we'll take a question and see how it works as far as method is what concerned. Are you hearing me?
Yes, sir.
Good. Now, the first one we're looking at, just like I said, we'll take a question on the risk adjusted method. Risk adjusted method. So we'll take the question and start solving. Stay with you. Almost there. Okay. Here's the question. Question 1 for this particular. So the one we're looking at, risk adjusted method. Question 1 is this. Question 1. Johnson PLC. Are you there?
Yes, sir.
Johnson PLC is considering. Johnson PLC is considering. Johnson PLC is considering a project costing 1.5 million. Is considering a project costing 1.5 million. Full stop. The project is expected. The project is expected to generate future cash flows. Future cash flows as follows. Future cash flows as follows. Are you there?
Yes, sir.
You move to the next line. Year. You write year. You now write cash flow. I hope you understand that. Year
Yes,
and cash flow. So year 1, the cash flow is 720,000. Year 1, cash flow is 720,000. Year 2, cash flow is 630,000. Cash flow is 630,000 naira. Year 3, cash flow is 300,000 naira. Year 3, 300,000 naira. Year 4, 270,000 naira. Is it clear?
Yes, sir.
Good. You move to the next line. The risk-free rate. The risk-free rate. The risk-free rate. The risk-free rate is currently 10%. Risk-free rate is currently 10%. Full stop. The company requires a risk premium of 7%. A risk premium of 7% to compensate riskiness of the project. To compensate riskiness of the project. Full stop. Are you there?
Yes, sir.
You are required to analyze the effect. You are required to analyze the effect of using the risk-free rate, and risk-adjusted discount rate. Risk-free rate and risk-adjusted discount rate on the viability of the project. On the viability of the project. Are you there?
Yes, sir.
Good. We'll solve that now. I will do that. I'm going to use formula. It will be faster. You know that our formula now, MPV,
Yes, sir.
MPV is still working. That is one of the best method of adjusting all these things. So I move. Put it on the board so that we can see it clearly. Good. So risks adjusted discount rate. The first thing we will do, we must calculate an MPV that is risk-free first. Okay, sorry, let me put the formula on the board first of all. MPV RAGR. That is MPV for risk-adjusted is given as summation of maybe A, C, all over 1 plus RA brackets raised to power T starting from 1 to what? N minus CO. I hope you remember CO.
Constantly.
Good. That A also can be CT, doesn't matter. So let me even use C, there's nothing wrong. Let me use T2 out. See? CT. So that means for you to calculate this, the only thing I believe that is not clear here, our N, we know is number of years. Our T is number of the period. CT, you know, is cash flow, Abi?
Yes.
Good. The only thing that I want to explain here is RA. RA is equal to RF plus risk premium.
Okay, RF.
In this our question, this is 10%.
Okay, RF plus. Is it plus?
RA. 1 plus RA. Okay, this is plus. Yes.
Okay.
No, this RA is equal to RF. That RF is risk-free plus risk premium. That could be PF or whatsoever. So this will now give us 17%. So for us to calculate risk-adjusted discount rate, we must add the risk-free to the risk premium to give us a total. But first of all, we're going to calculate 2 MPV. One is MPV for risk-free. We're going to use 10% for that one. Second calculation will be 17% to know how risky the business is or whether we're going to accept or reject. But the risk-free is just for us to do the normal calculation. Where we're going is the RAGFR. Is it clear?
Yes, sir.
Can I clean the board?
Yes, sir.
Good. So what we are doing now in this one is to say MPV RF will be equal to CT for this one of 1 plus RF. Or must calculate this one first. The question said so. T equal to 1 to N. Minus CO as usual. So our calculation will go towards MPV. If you like, you can write RF. So that question will copy. What was the first one? 720,000, Abi?
Yes.
720,000, is that the first year one?
Yes.
Check. So it's going to be 1 plus 10%. 10% now, that will be 1.1 raised to power 1 plus, what's the next one?
I'm coming, sir. 1 point. Okay. How did you get a 1.1? Okay, 10%.
10%, 1 plus 10%, that's 1.1 as usual.
Plus,
Remember, you must calculate the risk-free first before you calculate the risk-adjusted discount rate. Is it clear?
yes, sir.
You remember the question said we should show how it will affect the risk-free and the other one. So that's why we must carry the two together. Next, what's the numbers value?
630,000.
630 all over our 1.1, which is year 2, plus the third year is what? 300,000.
300.
Good, I remember that one. All over 1.1. Year 3 plus the last one is 270, Abi.
Yes.
All over 1.1 all raised to power 4 minus CO is 1.5 million, Abi.
Yes, sir.
Good.
720 is the year 1, year 2, year 3, year 4. Okay. I'm with you, sir.
No. Year 1 is 720,000, Abi.
Yes, I'm with you.
Good. 720,000. I'll put the last 0. So 720,000, 630,000, 300,000, 270,000, and then minus 1.5 million. So what you are going as usual now, you press your calculator, 720,000 over 1.1 plus 630,000 over 1.1 raised to power 2 plus 300,000 over 1.1 raised to the power of 3 plus 270,000 over 1.1 raised to the power 4 minus our value there. So we can find out what it is. Are you calculating?
Yes, sir.
Good. What's the result?
I'm on it, sir. $85,027.3.
35,000.
85.
Okay, 85,000.
And
85,000
27.3.
alone. 85,000 what?
85,027.5.
Okay, 27.5. And this is positive, Abby.
Sir? Yes, positive.
It's positive.
Huh?
I said
Hello?
it is positive.
Yes.
That means you have subtracted the 1.5 million.
Yes, sir.
Good. So that means the risk-free is positive. Now, we want to now find out whether this project is riskier or not. And that is by trying the next one, which is the risk. So with the risk-free, the project is good, we can accept it. But that is not what we're looking for. If we now check the risks adjusted, if it's positive, that means this project is not risky. We should go ahead and implement it. But if it's negative, it means that the project is risky and unacceptable for implementation. Is it clear?
Yes, sir.
Can I clean the board?
Yes, sir.
Huh?
Yes, sir.
Good. So now we repeat almost the same thing, but just in a different way. This one is now the RAGR, risk adjusted discount rate. Our formula will not change. It's now going to be 720,000, Abby?
Yes, sir.
All over. Our RA will now be 17%. Agreed?
Sir? Yes.
So it will be like this. Plus, the next one is what? After 720,000, what's the next one? 630.
Yes.
Good. All over 1.17 raised to power 2 plus 300,000 all over 1.17 raised to power 3 plus 270,000, I believe, all over 1.17 raised to power 4 minus our CO, which is 1.5 million. So our answer we're expecting. Oh, yeah. The same thing you did before, this time around is 1.17 because 17%. For the risk adjusted discounts for the risk adjusted rates, discount rates.
Minus
What do you have?
92,000
Minus
92,995.2.
92. Have you
Minus
subtracted
minus
92?
yes,
That 92, now they worry me.
995.2.
That 92, now they worry me.
92,000.
To me, it looks as if.
Sir?
Okay, I'm coming. Let me check my own. I'm coming. Okay, I'm looking at it. It shouldn't be that much. 92, Abi?
Yes, sir.
982, Abi?
Yes, sir.
Okay, good. So,
No,
92,000.
92.
Okay, 92.
92,995.
Okay, 9. Okay, let's believe it. Doesn't matter. That one is okay. That one was tabular. This one is our calculation. So you can see from all indication, because the risk adjusted discount rate is negative, it shows that this project is risky. and is not viable. So the company cannot accept this project. They cannot execute it. Is it clear?
Yes, sir.
It means this is risky and it's not viable, and therefore is unacceptable. That means we reject this project because it has a negative MP. So that's all about risk adjusted discount rate. Is it clear?
Yes, sir.
That's to tell that if you know MPV, most of the calculation involving project evaluation in this course is very easy. So we're moving on to the next agenda, which is certainty equivalent approach or method. You know, why this one I just did? This one is just after the interest rate, is attacking the interest rate to see how, whether the business is risky or not. But the next one is after removing risks from the cash flow. This one is talking about the cash flow. There will be having what we call certainty equivalent coefficient. But let's see how it works. Okay, that's all for that one. Question 2 for today. Question number 2 for today. Certainty equivalent method. Have you written that?
Yes, sir.
Certainty equivalent method. We'll take a question to that effect. Question number 2. And it goes thus. This is a question. Very short also. OB PLC. Question 2 for today. OB PLC is considering a project with the following cash flow estimates. OB
Come again, sir.
PLC.
Okay.
Question 2. OB. Have you heard that one?
Yes, sir.
OB PLC is considering a project with the following cash flows. Are you there?
Yes, sir.
Following cash flows estimates. You will agree with me? Here, you write the year and the cash flow. Year 0, 7,500. You know, it's a minus of bracket, Abi. Hello?
Minus.
Either I put minus or I put bracket, anyone you like. Year 1,
Year 0 is what?
5,250. No, year 0 is 7,500. 7,500. Bracket or minus, anyone you like. Year 1, 5,250. Year 1 is 5,250. Year 2, 4,250. 4,250. 4,250. Year 3, 4,800. Year 3, 4,800. Are you there?
Yes, sir.
Year 4, 4,200. 4,200. Year 5, 3,000 naira. Year 5, 3,000 naira. 3,000. Continue. The value of, let me show you what I want to write so that you can see it clearly. Watch, you see this symbol. Are you seeing this alpha?
Yes, sir.
Good. So you're going to say the value of alpha. This alpha simply means certainty equivalent coefficient. So just write that symbol for me. The value of that symbol varies between 0 and 1. Varies between 0 and 1.
Sir? Varies
Between 0 and what? 1. That symbol I gave to you is what we call, what is it called?
certainty equivalent coefficient.
So I just want to give you an idea that that alpha symbol varies from what? 0 to what? 1. So that you can understand the rating we are doing. The value of alpha varies between 0 and what? 1. Depending on the riskiness of the project. Depending on the riskiness of the project. Are you there? Depending
Yes,
on the riskiness of the project. Full stop. The lower the value of alpha, the lower the value of alpha, the higher the perceived risks of the project. The lower the value of alpha, the higher the perceived risks of the project, and vice versa. Our question is still where it is. I'm trying to explain something so that you can understand. Is that okay?
Yes, sir.
So to conclude our question, is our question now. That place you wrote, you know, you wrote year 1, Abi?
Yes.
So you have written on top, that same place, you have written year, cash flow. The next column, you are going to put alpha. This is what you're going to put for me.
Okay, sir.
You know, you have written here. You have written here before. You have written cash flow. Now you now write alpha in base T. So that means already you have written 0 here. You wrote 75 here. Here will be a value 9. Is it clear?
Yes, sir.
You go back to that question. I'm only saying, let me explain the meaning of alpha before I fix that so that we can solve. So now, always, year 0 will always be 1. Year 0 is 1. It won't change anytime, any day. Because now our project cost cannot be changed for any reason. Our project cost cannot be influenced. So our alpha T, which is certainty equivalent coefficient, will not change. So 1. Year 1, 0.9. Year 1, under it, 0.9. Year 2, 0.8. Year 2, 0.8. Year 3, 0.6. Year 3, 0.6. Year 4, 0.4. Are you with me?
Yes, sir.
Good. Year 5, 0.3. So that's the question.
What is year 5?
It's also very easy. Have you gotten it?
Year 5 is what?
Year 5, 0.3.
Okay, sir.
Year 0 is 1. Year 1 is 0.9. Year 2 is 0.8. Year 3 is 0.6. Year 4 is 0.4. Year 5 is 0.5. Is it clear now?
Yes, sir.
Good. Now, this one, remember, it is certainty, equivalent, approach. So our solution will be MPV. We'll put down there SCE. You know the meaning of C in IB, certainty equivalent. It's going to be, there's the formula, alpha C over 1 plus. Can you see it? Okay. 1 plus. This one is always risk-free. Raised to power T. Summation. T starting from 1. Raised to power N. And as our CO, it doesn't change. Still the same thing. Our risk-free here, we'll use 10%. Is that okay? You know, we had 10% before, Abby. Where alpha T is certainty equivalent coefficient. Certainty equivalent coefficient. Which one is to explain there? RF, we know that before. Risk-free rates. There's not that thing to explain there. We know the rest. We know what is T. We have seen the other one. So risk-free rate, the formula is very clear. So we are believing that our risk-free rate in this question is 10%.
Hello, sir.
RF. Our RF is 10%. Are you there?
Hello, sir.
Can you hear me?
I can hear you. What I'm saying, the question I want to ask is this. This MPV, okay, MPV certainty equivalent, that is the formula.
Yes, that's for this one. So that one was MPV RADR. This one is CE, telling you certainty equivalent method.
That is alpha T multiplied by.
Yes. Remember that alpha T is the, what is it called? Certainty equivalent coefficient, which started from 1 over 9 down to 0.3. So it's still, as far as you understand MPV, discount adjusted risk rate is certain. This one we're doing is also certain. And the one we're going to do next, if the time permits, is also certain. Can we continue?
Yes, sir.
Okay, good. So now we have agreed that the risk free is 10%. So our solution to that.
Have you wrap it off?
Hello?
I'm with you, sir.
Okay. So you have
Mommy.
MPV, certainty equivalent. How much? The first one was year 1 was how much?
Sir?
Year 1, 0.9, I believe.
0.9, yes, sir.
Our cash flow is how much?
Sir?
5. You know, there is year 1. How much is the cash flow for year 1?
5,250.
Good. Over 1.1 raised to power 1 plus. The second one is 0. What?
0.8.
Year 2. How much is the other money? Year 2 cash flow.
4,250.
Over 1.1 raised to power 2 plus the other one called 0. What?
0.6.
Year 3. 6. What's the cash flow for year 3?
4,800.
4,800. Those who like tabular form can also do table. But I believe this one is more easy, Abby,
Yes, sir.
than all those stress of 0.4, Abby,
Yes.
times, is it 3,000 what? Year 4?
4,200.
Good. Raised to power 4. And finally, plus 0.3, I believe. 3,000, Abby.
Yes, sir.
Minus our CO. Our CO is
7,500.
7,500.
Yes, sir.
I know that that one is 7,500. Our other, what is it called? Certainty equivalent is 1, which is of no effect, Abby.
Which one is that?
You know, year 0. Year 0 is the CO, Nabi.
Yes.
And that certainty equivalent coefficient is 1. And
Yes,
that
sir.
one is of no effect, Abby.
Yes, sir.
So I just put it there for putting stake. Even if I put over 1.1 raised to the power of 0, it will not amount to anything. So it's just, this one is just formality. So the answer is just minus 7,500. So how much now? Calculate for me. So you're going to run it 0.9 into 525 all over 1.1 plus 0.8 into 4, that is times 4250 divided by 1.1 raised to power 2 plus 0.6 into 4800 all over 1.1 raised to power 3 plus 0.4 into 4200 all over 1.1 raised to power 4 plus the last one 0.3 into 3000 all over 1.1 raised to power 5 and minus 7,500 alone, which is the cash outlay of the project cost. So calculate. Are you running it?
Yes, sir.
Good.
4,000. Jesus. 1,575.5.
1,000.
Yes,
1,000.
575.5.
575. 75.5. Okay. All I know is that it's positive, but maybe if there's small error there, but all matters is that the MPV is positive, and that means the project is worthwhile.
Viable.
So we should accept, yes. So that's all about certainty equivalent analysis. Is it clear?
Yes, sir.
We'll take the last one, if you are true. The last one is what we call sensitivity. That one we must use table. We will not run a formula like this one. We'll do a table and do some small calculation. But it's also not difficult. Are you ready?
Yes, sir.
The thing is sensitivity analysis approach. That's the one. And which is the third one, sensitivity analysis. So question 3 for today, or question 1 for sensitivity analysis. A project has the following features. A project has the following features. Are you there?
Yes, sir.
Hold up. Next line. Project cost.
Following what?
750.
Features.
Following, yes, FEA. Features. Column. Next line. Project cost. 750,000 naira. Project cost. 750,000 naira. Are you there?
Yes, sir.
Next line. Estimated number of years. Estimated number of years. 6 years. Residual value. Nil. NIL.
6 years.
6 years. 6 years. Yes. 6 years. Residual value. Nil. 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 There's no value. Estimated annual sales. Estimated annual sales. 1.2 million. Estimated annual sales. 1.2 million. What that one simply means that every year be
Yes.
1.2 for 6 years. Next, estimated annual production. Estimated annual production. 960,000 naira. 960,000 naira. Discounted rates. Discounted rates.
Estimated annual production.
Yes, estimated annual production, 960,000 naira. 960,000 naira. Discounted rates. Discounted rates. 16%. Are you there?
Yes, sir.
16%. You are required to calculate. You are required to calculate the sensitivity margin. Sensitivity margin. I hope you know that margin is profit over selling price. Have you?
Sir?
In accounting. I hope you know that margin is profit over selling price in accounting. Have you?
Yes, sir.
Good. And in this case, margin means fraction. Margin means ratio. There will be a numerator and there will be a denominator. So sensitivity margin of the following. Sensitivity margin of the following. Roman figure 1. Sales per annum. Sales per annum. Roman figure 2. Production cost per annum. Production cost per annum. Roman figure 3. Project cost. Project cost. Roman figure 4. Useful life of the project. Roman figure 4. Useful life of the project. Are you there?
Yes, sir.
That's the question. I'm going to start the solution now. This question will involve small calculation, which will not be difficult. That means there will be items. Items we are going to put in table is project cost, which you know is times year 0, Abi. Hello? Are you still there?
I'm with you, sir.
Good. I said what we are going to be considering is items. Solution to that question will start with items. The item will first of all is project cost. And that project cost, you are aware, must be a zero. We're going to look at the sales revenue, the annual sales from year 1 to year 6, which is 1.2 million. We're going to look at the production cost, which is also from year 1 to year 6. We're going to do a table as usual, the cash flow. We're going to do discount factor. We're going to get the present value. And we're going to get the MPV, which you know already. So we'll start. So that to be clear. This one is sensitivity. Sensitivity. Sensitivity analysis. That's what we're looking at. And in this item, we have items. Items. The first item is project cost. The next one is the year. This is year 0. The next one is the cash flow, which you know, 750,000, Abi?
Yes, sir.
With a bracket. The next one is discounts. How many percent?
Sir?
16%, Abi?
Yes.
The next one is present value. So this one is sales. Sales revenue from year 1 to 6, agreed? Production costs. Production cost. Also, we'll start from year 1 to year 6. This one is 1.2 million. This one is 960,000. This one will also have brackets because the question has mentioned cost. Is it clear?
Yes, sir.
So this is the arrangement. Because that first one is normal, production cost, you know, is 0, 750,000, there will be a bracket. Second one is 1.2 million, there won't be a bracket because it's a cash inflow. The project cost is cash outflow. Production cost is also cash outflow. And that's why there's a bracket attached to it. Is it clear?
Yes, sir.
I hope you have not forgotten our formula. 1 over 1 plus R raised to power n. So discount factor, this should be 1, Abi.
Yes, sir.
Good. Good.
So,
Now,
but this amount, the 750,000, what is it called?
yes, that's what it's there now.
Estimated annual sales. I think it is 1.2 million per year.
Yes, now per year. Have you seen what I wrote there? 1 to what?
To 6.
That means year 1, 1.2, year 2, 1.2, year 3, 1.36. And we can't be writing it 1, 1, 1 like that 6 times. Can we be doing that?
So I'm okay. That was why you put
1 to 6.
12 million.
No. It's 1.2 million that is there. That's
Okay,
what I wrote in the year 1 to 6.
So we only take 1 year.
What we have done is that you have seen in the year from year 1 to year 6. Did you understand that?
But what I'm saying is it's supposed to be 1.2 times 6 now.
No, we are not timing anything. You will see how I go do it. But you have seen 1.2 million, Abi?
Hello?
1.2 million. Have you seen that?
Since it is 1.2 million per year, it's supposed to be 1.2 times 6.
No, see now, see. You have seen 1 year to 6, Abi. Are you not seeing 1 to 6?
Yes.
That's it, man. That means that 1.2 million will be from year 1 to year 6. Ordinarily, this is what we would have done. Would have written sales revenue year 1, 1.2 million. Under sales revenue year 2, 1.2 million. Year 3, 1.2.
No, that is what I'm saying. Since we are,
But
we are,
you can't be thinking that when we can arrive from year 1 to 6, it's okay.
Since it is 1 to 6, I think it's supposed to be 1.2 times 6.
No, we don't do that. It is 1
I'm
to
coming.
6 that will help us to do what we want to do. Have you seen the arrangement? That's year 1 to year 6. You know, that first one, project cost, was just 0, Abi.
Yes.
Now, instead of writing sales revenue year 1, year 2, year 3, year 4, year 5, year 6, we just write the year that this 1.2 million will start from year 1 and end at year 6. We don't need to change the 1.2 million. It's our discount that will determine what to do.
Okay, no problem, sir.
Good. And the same thing with the production cost. It's also run from year 1 to year 6. So it's the number of years we have to look at 1 to 6. But the value will be
okay. I'm very sorry. I now understand it.
No, you don't need to be sorry. It's part of the lecture.
It is estimated annual sales. That is the total.
Yes. So no problem. We are all learning. No wahala. But now that you have gotten it, we can move. Now, I gave you a formula one time. I don't know whether I remember. There's a formula one time that I gave. That formula is present value of ordinary annuity. If you can recollect, the formula was 1 minus bracket to 1 plus r raised to power minus n all over r. You recollect?
Yes.
Good. That formula, I want you to use it. The r is 16%. So this is what you're going to press. When they give you year 1 to 6, that's the formula to use. Or I'll tell you the second thing to do. First, whenever you see 1 to 6 or 1 to 10 or 1 to 20 or 1 to 30, that present value ordinary annuity discount factor, which is 1 minus bracket open 1 plus r, close the bracket, raised to power minus n. The whole of the numerator divided by r is the formula to use to get the answer as fast as possible. So this is what you are going to press for me. You are going to press 1 in your calculator. Are you there?
Yes, sir.
You press 1 minus 1.16. I hope you know I got 1.16.
Yes.
That 1.16 is raised to power minus 6 because the last year is 6 years, 1 to 6. So that n will be 6 minus 6.
That's
so what's
0.000.
Is that what you got as numerator?
No.
No. I said you should press 1 minus bracket open 1.16.
My calculator can open bracket too. Maybe we write it.
A bracket there now. Okay, let me show you. But have you copied this on the board?
Yes.
Good. This is what I mean.
Yes, I understand now. 1 minus what?
1 minus your calculator has bracket. I know, see.
Yes.
Every calculator has bracket. So 1 minus bracket open 1.16 bracket close raised to the power of minus 6.
Minus 6.
Have you done that?
Yes, sir.
What's your answer? Your press answer. Let me hear.
0.58.
Good. That's your answer. Divided by r. R will be 0.16. Divided by 0.16. What do you have now?
3.685.
684 something.
3.68473.
47. Good. Is it clear?
Yes, sir.
If you don't like that method, this is what you will do for me. Press your calculator like this. 1.16 raised to the power minus 1 plus 1.16 raised to the power minus 2 plus 1.16 raised to the power minus 3 plus 1.16 raised to the power minus 4 plus 1.16 raised to the power minus 5 plus 1.16 raised to the power minus 6. Press the answer. It will be the same thing with this.
Come again, sir.
You know, our normal formula is 1 over 1 plus r raised to the power n, Abi?
Yes. Which one are we calculating now? Is it the discount factor?
Wait. Is discount factor right? We know we have gotten 3.6847, Abi?
Yes.
Using that present value, ordinary annuity. If one has forgotten that formula, but at least you can still remember our normal formula, 1 over 1 plus r raised to the power n, Abi?
Yes, sir.
I know that 1 plus r raised to the power n is inverse, is down. So we can make it 1.16 raised to the power minus 1 for year 1 plus 1.16 raised to the power minus 2 for year 2 to year 6. And you press answer, you will get the same answer.
So how
Did you
do we continue
understand?
to, yes,
You just
this
press your calculator.
this discount factor now, are we going to apply it to both the revenue
Yes.
and
We're also applying it to the same amount. I don't want to tell you alternative way of doing it in case you are in exam hall and you cannot remember that present value of annuity to run 1 to 6. You can still use our small formula. Your calculator can do it. Just press 1.16, which is the same thing as 1 over 1 plus r raised to the power n. So we can take it inverse, law of indices. So 1.16 raised to the power minus 1 plus 1.16 raised to the power minus 2, that is the year 2, plus 1.16 raised to the power minus 3, plus 1.16 raised to the power minus 4, plus 1.16 raised to the power minus 5, plus 1.16 raised to the power minus 6. When you press the final answer, you get the same thing on the board. Is it clear?
Yes, sir.
Okay, you can try that one later. But let's multiply this. This first one is 750,000. Is it clear?
Yes, sir.
So help me multiply the other one. 1.2 million times 3.6847.
That is 4,421,640.
4,421,640. 640. Okay. Then the other one, uncle, 960,000. 960,000 times 3.6847. What do you have?
3,537,537.
3,537,312. 312. This one we have bracket, I hope you know.
Yes.
So our MPV will equal to what? Add them together.
Yes, sir.
Should give us, that means 750 will be minus 4,421,640. That means minus 750,000. plus 4,421,640 minus 3,537,312. What do you have?
$134,328.
Good. Here's our MP. Is it clear?
Yes, sir.
We'll now start the analysis. Roman figure 1 made us to understand. Have you copied this?
Yes, sir.
Okay. Have you copied?
Yes, sir.
Because we need the values. So the next thing now will be Roman figure 1. Are you there?
Yes, sir.
Let me just run that. Roman figure 1. So write for me. Because this one does not involve too much stress. Sensitivity margin. Are you there?
Yes, sir.
We're answering Roman figure 1 now. I haven't gotten the MPP stop. So Roman figure 1 will be sensitivity margin of sales per annum. Sensitivity margin of sales per annum equal to, are you there?
Yes, sir.
MPV, that's your numerator, MPV over present value of sales, MPV over present value of sales. Is what I mean. MPV over present value of sales times 100/1. Is it clear now?
Yes, sir.
Net present value. You know, we just got net present value now, Abi?
Yes, sir.
And there is present value for sales. So all I need to do is to write 134, is it not 2 what? 328, Abi?
No. Present value of sales is 4.
No, wait, no. Numerator, MPV. 134,328. Is it clear?
Yes, sir.
Over 4421,640. Is it clear?
I still don't understand. Okay, that is 1 point.
You know, Shebi, you saw the formula.
Yes.
MPV, which we just calculated now, is our numerator.
Yes. It's 134.
Yes. Remember, there is a difference between MPV and present value. MPV we just calculated is 134,328. Present value
of sales.
If you go back to that our table, we got 4,421,640.
Yes. Yes, sir.
That is the present value of sales. Is it clear?
Yes, sir.
So you put it 134,328 numerator over denominator 4421,640 times 100/1. Or you run the calculator. What's your answer? Press your calculator. 134.
3.037.
No. I don't agree yet. Don't agree. Press this calculator very well. Numerator 134,328 over 4421,640 times 100/1. What do you have?
That is times 100 now.
Yes, now what do you have?
I'm coming, sir.
You for take that numerator, divide the denominator. It is at the end of that division, you now multiply by 100. You should not multiply the denominator by 100. It's when you have taken numerator, divide by denominator, your result, you now multiply by 100.
That's what I'm saying. 3.0379.
Okay, 3.0.
Yes.
So that means approximately 3%, Abi?
Yes.
Good. So we'll now make a statement. Are you there? Write the statement. I haven't gotten 3% for the sensitivity margin of sales. This is our discussion, or this is our reason. Sales. Are you writing?
Yes, sir.
Sales must not be reduced by more than 3% if we must make profit. Sales must not be reduced by more than 3%. That means if we reduce sales by 4%, there will be an issue. Is that okay?
Yes, sir. Okay. Sales must not be reduced by more than 3%.
By more than 3%. We should not go above that. We should not go above 3% so that we can maintain margin. Margin means profit. I hope you understand.
Yes, sir.
So that we can maintain margin. That is Roman figure 1. Gone. I just want to finish this. This class is supposed to have gone, but let me just make sure I finish this. Roman figure 2. Are you there? Because it's similar.
Yes, sir.
There's no more. Roman figure 2. Sensitivity margin. Sensitivity margin of production cost. Sensitivity margin of production cost equal to MPV numerator. It's still following that same formula. MPV over present value of production cost times 100 over 1. I hope you understand now. MPV numerator all over present value of production cost times 100 over 1. Is it clear?
Yes, sir.
So equal to, our numerator hasn't changed. 134,328 over 134,328 over that our present value in that question, which is 3,537, 3,537, 312, 3,537, 312 times 100 over 1. So you calculate, what's the answer?
$3.79.
So that's approximately 4%, Abi?
Yes.
So the analysis that will follow, comment. Production cost. Production cost must not increase. When it is revenue, we say it should not reduce. When it is cost, we say it should not increase. So production cost must not increase by more than 4% per annum. Production cost must not increase by more than 4% per annum. Is it clear?
Yes, sir. Per annum.
Yes, per annum. I take the third one, but that fourth question will be done next on Tuesday.
Okay, sir.
That one involves too much calculation. It will involve equation and so on. So that's the length. So we take this third one. That fourth one will be concluded in the next class. Roman figure 3. Are you there?
Yes, sir.
You can see that today we did not have break, Abi.
Yes, sir. So till next week.
But let's just take this 3. Roman figure 3. Sensitivity margin of production cost. Sensitivity margin
We've
of
done that
production.
one
now. Sorry. Sensitivity margin
of
project cost. I'm on call. Let's start with P. Project cost equal to MPV as numerator over present value of project cost. MPV over present value of project cost times 100 over 1. Our formula hasn't changed. Numerator is 134,328 over 750,000 over 750,000 times 100 over 1, as usual. What do you have?
$17.9.
That means 18%, Abi, approximately.
Yes.
So the comment that follow finally, the cost of the project. The cost of the project should not, the cost of the project should not be allowed to rise or to increase, by more than 18%. Is that clear?
Yes, sir.
By more than 18%. Any queries? On that note, we'll continue with that Roman figure one, which means the topic is over. By the time we come, we'll look at another interesting topic. Do you still remember leverage?
Sir?
We have done capital budget under certainty. We have done capital budget under uncertainty. We have done mathematics of finance. We have reviewed the beginning. Do you know leverage?
No.
Okay, so the next topic will be leverage.
Okay, sir.
On that note, that's all we can take for today.
Thank you, sir.
God bless you. See you
Yeah, now
soon.
you too, sir.